laureate Hans Bethe said, "I have sometimes wondered whether a brain like von Neumann's does not indicate a species superior to that of a man. He dined with presidents, cracked Nazi codes, helped build the first atomic bomb, laid the foundation of quantum mechanics, revolutionized computers, and in his spare time casually invented game theory. John Von Neumann. And chances are your entire digital life still runs on the architecture of his brain." Born in Budapest to a wealthy Jewish family, von Neumann was less a child and more a phenomenon. At 6, he could divide two 8-digit numbers in his head faster than his father could write them down. At 10, he was fluent in Greek, Latin, German, and Hungarian, casually quoting classical literature. He had what people now call photographic memory. Glance at a page once, and it was locked in his mind forever. One colleague even recalled asking him how A Tale of Two Cities by Charles Dickens started. Without missing a beat, von Neumann began reciting it and didn't stop for at least 10 minutes. His recall was legendary. He could memorize entire phone books and translate technical papers on the spot into English from other languages. Though his father insisted he attend school with children his age, he still hired private tutors to feed Johnny's insatiable mind. By 15, he was mastering advanced calculus like a seasoned scholar. His father thought math couldn't pay the bills, so von Neumann agreed to study chemical engineering at ETH Zurich, while simultaneously enrolling in a mathematics PhD at the University of Budapest, where he wrote his thesis on set theory. By 23, he was the youngest professor at the University of Berlin. Soon he was working alongside David Hilbert, one of the greatest mathematicians in history. As fascism rose in Europe, von Neumann was invited to Princeton's Institute of Advanced Study, an academic paradise with no students, no classes, just raw genius. There, he rubbed shoulders with Einstein and Gödel, and yet he often outshone them in calculations. Colleagues called him a human calculating machine. He would sleep for a few hours, wake up with a solution, and solve complex equations before breakfast. But von Neumann wasn't just a calculator. He was a machine that dreamed. Genius, it turns out, can be charming and chaotic. Von Neumann loved fast cars, lavish parties, and philosophical banter. He could outdrink generals and outwit codes, but he was also deeply distracted, often lost in thought, even mid-conversation. He married twice. The first ended in divorce, and within a year, he married Clara Dehn, his childhood sweetheart. He adored his daughter Marina, but fatherhood was hard to juggle with national security meetings and late-night equations. She wrote that he was very concerned with his legacy in two aspects: his life and the durability of his intellectual contribution to the world. Friends described him as warm, hilarious, dangerously brilliant. He would help anyone, novice or a Nobel laureate, with a math problem. His colleague, Eugene Wigner, once said, "Nobody knows all science, not even von Neumann, but as for mathematics, he contributed to every part of it, except number theory and topology." Apparently, these two topics made von Neumann a bit uncomfortable. Von Neumann found himself entangled in a different kind of revelation, one that would change the course of history, not just science. During World War II, he became a key figure in the Manhattan Project, the top-secret U.S. initiative to develop the atomic bomb. Von Neumann applied shockwave theory to calculate the bomb's detonation, and his insights helped shape the implosion method used in the Nagasaki bomb. It was science under pressure, cold logic in the service of devastating power. For von Neumann, the line between war and equations had all but disappeared. He sat on the target selection committee, calculating blast radii, death tolls, and the perfect altitude for detonation. And then he kept going, helping drive the hydrogen bomb project forward with Edward Teller. Enrico Fermi once said to Herbert Allenderson, "Johnny can do calculation in his head 10 times faster than I can. And I'm 10 times faster than you." Von Neumann's lectures were dazzling, so rapid and clear that even taking notes was a challenge. If a professor posed an open problem, Johnny often returned with a full solution before the class ended. And von Neumann, he was humble about it. He once said Gödel would be remembered with Pythagoras. But me, he said, I will be forgotten. Von Neumann's name echoes through quantum mechanics and physics. He provided the mathematical foundation for quantum mechanics, including the idea of the wave function collapse. He also introduced the von Neumann entropy, density matrices, and quantum logics, all of which remain central to modern quantum theory. Von Neumann joined the ENIAC project, the first general-purpose electronic computer. But he saw something others missed. Why not store the instructions inside the machine? This concept, the von Neumann architecture, is the reason your phone, laptop, and even the Mars rover works. He introduced the stored program concept, published in the first draft of a report on the EDVEC, and further designed the flow of logic still used in computer systems today. This is the IAS machine, a marvel of its time, and arguably the most important machine you've never heard of. Designed in the late 1940s under von Neumann's direction at the Institute of Advanced Studies. This was no ordinary device. What you're seeing isn't just hardware, it's the prototype of modern computing. Every smartphone, every server, every AI model we use today is built on the foundation laid by this beast. Binary memory, central processing, stored programs, all born here in these wires and vacuum tubes. Von Neumann saw life itself as a game of chance, of strategy, of calculation. He co-wrote Theory of Games and Economics Behavior, further founding game theory, a mathematical toolkit now used in economics, AI, politics, war, and even pandemic response. A fun twist? He thought poker was boring, because once you understand game theory, it's too easy. In 1955, a mass was found near the von Neumann's collarbone, which turned out to be cancer. He confided to his mother, "There probably has to be a God. Many things are easier to explain if there is than if there isn't." As death neared, he asked for a priest. Though the priest later recalled that von Neumann found little comfort in receiving the last rites, he remained terrified of death and unable to accept it. It is also said that the government kept a guard by his deathbed to be sure he didn't divulge any state secrets while on mind-numbing pain medications. He died a Roman Catholic at 53 and was buried in Princeton Cemetery. Edward Teller observed von Neumann would carry on a conversation with a 3-year-old son, and the two of them would talk as equals. And sometimes he wondered if von Neumann used the same principle when he talked to the rest of us. Wigner noted the extraordinary mind that von Neumann had, and he described von Neumann as having a mind faster than anyone he knew, stating that, "I have known a great many intelligent people in my life. I knew Max Planck, Max von Lowe, and Werner Heisenberg. Paul Dirac was my brother-in-law. I have been among my closest friends, and Albert Einstein was a good friend too. And I have known many of the brightest younger scientists, but none of them had a mind as quick and acute as John Von Neumann. I often remark this in the presence of those men, and no one ever disputed me. He once said he feared being forgotten. But to this day, those who work with logic, computation, and chaos still whisper his name with awe. Because behind everything the modern world runs on is the architecture of von Neumann's mind. From the nuclear age to the digital era, from the quantum world to the AI revolution, from poker tables to Mars, we are all just catching up with Johnny.